something's wrong with Jupiter's aurorae. Although they are observed at both poles, X-ray aurorae have only been consistently spotted in the north. Now, a new Nature astronomy study has revealed that a persistent southern X-ray aurora has finally been observed, but weirdly, it acts independently of its northern counterpart. Scientists have long been baffled by the mechanisms by which these glorious light shows are produced on Jupiter. This new paper, led by University College London, UCL, planetary scientists, brings up more questions than it answers. How does Jupiter produce bright, energetic, and dynamic auroras while its sibling, Saturn, does not? William Dunn, an astrophysicist from UCL, said to Ifelscience. Dunn described the discovery of the southern aurora via the XMM Newton and Chandra X-ray satellites as confusing, and although he and his team have several ideas as to how it comes about, they hope that the Juno mission will ultimately help solve the mystery. Aurorae on Earth, whether you're nearer to the Arctic or the Antarctic, are generally weaker than Jupiter's, and they're formed via a different mechanism. When extremely energetic electrical fields accumulate along Earth's magnetic field lines, triggered by anything from regular solar wind to a highly energetic solar flare, electrons are rapidly accelerated towards the ground. When they collide with molecules in the atmosphere, they become energetically excited, and when they calm down again, they release photons that appear to us as aurorae. You can actually tell what molecules have been hit based on the color of the ephemeral, dancing dragons. Oxygen procures yellow-green hues, and nitrogen produces more red-violet shades, for example. Either way, they're very much dependent on the incoming solar wind. Jupiter is, in all respects, far more alien. Unlike ours, which we see in the visible part of the electromagnetic spectrum, both the northern and southern lights there are dominated by X-rays. To make these X-ray signatures, the planet needs to accelerate oxygen ions to 5,000 kilometers (3,107 miles) per second, enough to completely strip oxygen of all its electrons, Dunn explained. Although they are out of sync with each other, their appearances can be described as powerful pulses that happen like clockwork. The southern X-ray outbursts, for example, seem to happen every 11 minutes, but it's unclear as to why they're so regular. The electrical fields near Jupiter's poles are around 30 times stronger than Earth's. Weirdly though, the aurorae don't seem to appear around them, which suggests they aren't causing them. It's been proposed that ripples in the Jovian atmosphere are allowing electrons to accelerate enough to cause aurorae. This is generally thought to be a result of the planet's own rotation, but it was also observed quite prominently back in 1991 when the catastrophic, multi-stage impact of comet Shoemaker-Levy 9 sent shockwaves through the atmosphere. Solar wind also has some influence, as does the volcanic debris jettison from nearby Io. Nevertheless, these ideas do not adequately explain the precise timing of the X-ray pulses, nor do they elucidate why they're so incredibly energetic. Dunn's team have a few ideas of their own, with one imagining the planet to be akin to a giant musical instrument. They suggest that when solar wind smashes into Jupiter's magnetic field, it causes the field lines to vibrate like the strings on a guitar. This vibration causes oxygen and sulfur ions to leap up and collide with Jupiter's atmosphere at breakneck speeds, which would explain both the timing and the high-energy nature of both the northern and southern lights. Their independent behaviors, though, is still rather difficult to explain. Only time will tell if they're correct, but until then, Jupiter will remain the solar system's largest planetary enigma. Thanks for your watching. Please share this video and don't forget to subscribe.